Welcome to VERTEX, a journey into the hidden architecture of our world, where science meets the unknown and evidence challenges belief. Tonight, VERTEX explores one of the most persistent riddles on Earth, a triangle drawn not by borders or nations, but by disappearances, instruments in revolt, pilots out of time, and a sky full of unanswered questions. Far from folklore, there is a record: logs and coordinates, weather reports, radar returns, pilot tapes, sonar maps, declassified memos, and testimony under oath. There are also stories of vortex tunnels and skies that fold, of ship decks left empty, and of objects that move as if inertia does not apply. Between the record and the stories lies the space where science works. Ask, test, repeat. They call it the Bermuda Triangle. But its edges bleed into history, into physics, into archaeology, into classified hangars in the Nevada desert, and into the silent vaults beneath nuclear missile fields on the Great Plains. This is a map of mysteries, and each waypoint leads to the next. The sea is calm as the sun drops behind Miami. On charts, the water is a gradient of blues, but the air carries a memory of events that have made mariners superstitious and scientists stubborn. Engines start, flight plans load, and a chorus of instruments clicks to life: barometric altimeters, directional gyros, magnetometers. In such a world, precision is comfort. Yet it is here, more than anywhere else, that precision sometimes dissolves. A logbook opens on a December afternoon, 1945. 5 Navy TBM Avenger torpedo bombers climb into a sullen sky call sign, Flight 19. The route is routine: east from Fort Lauderdale, bombing practice over the Bahamas, then turn north, then west to home. Radio discipline is crisp. The pilots are trained, the airframes reliable, the weather marginal but manageable. Then a voice cuts the predictable rhythm. Compass out. Another voice confirms. Across multiple aircraft, directional instruments disagree. Master and standby drift apart. Sun and sea flatten into a single gray. Shoreline cues vanish. Charts mean little if headings are fiction. They try to form on the lead ship. Navigation by dead reckoning becomes a guess. The radio transcripts tell of confusion, not panic, but the erosion of certainty. The last intelligible exchanges suggest a turn that should have returned them to Florida. Instead, the signals grow weaker. A PBM Mariner rescue plane takes off to find them. Minutes later, it too vanishes from radar and never returns. For days, the search grid expands: fixed-wing ships, every resource that can be launched. Oil slicks are spotted, debris is reported, none is confirmed. No wreckage, no life rafts, no bodies. The ocean keeps its silence. The official verdict: unresolved. The human verdict: something here does not behave as expected. It is tempting to mythologize Flight 19, but the facts are strange enough. Compasses can fail, gyros can tumble, weather can degrade. Yet 5 aircraft and then a rescue plane leave no trace: not flotsam, not a tail number, not a seat cushion in well-mapped waters. Pilots will tell you the sea is vast and deep, and that many aircraft have vanished elsewhere without conspiracy. Scientists will remind you of currents and time. Still, the case sits at the origin of the modern triangle story for a reason. It embodies a pattern navigation instruments acting oddly. Decisions that make sense on paper, but fail in reality, and outcomes that defy the statistics of recovery. Centuries earlier, before radar and torpedo bombers, another explorer recorded the same unease. In 1492, Christopher Columbus noted a great fire falling into the sea and a compass deviation near these waters. Did his crude magnetized needle waggle because of natural variation? Almost certainly. But it anchors a timeline. Strange readings here are as old as European maps. The camera drops beneath the waves. Sand plains stretch like deserts, interrupted by drowned escarpments and coral citadels. Sonar paints walls and right angles that stir the imagination, the so-called Bimini Road, a procession of stone blocks that some claim are ruins. Geologists point to beach rock fractured and aligned by currents. Archaeologists remind us that extraordinary claims require extraordinary evidence. Yet the allure persists. If an advanced city once stood here, if electricity and crystal towers powered engines beyond our current reach, might residues linger in the sea, unusual piezoelectric fields, a pattern of interference? The sober answer: no evidence yet. But the question refuses to die. The question becomes sharper in a cockpit 478 years after Columbus. A pilot named Bruce Gernon lifts off from Andros Island in 1970, bound for Florida. The weather forecast is acceptable. Ahead, a lenticular cloud, odd, but not alarming. As he approaches, the cloud forms a ring, then a tunnel. He proceeds inside, trusting instruments and training. The world turns white. Lightning crawls above the windscreen. Static dances on the propeller. A sensation of weight loosens from the seat. The altimeter insists. The radio crackles thinly. The compass jitters. Then, abruptly, clear air and blue. He calls ATC. Miami cannot find him on radar, where he should be. Then they find a target far closer to shore, impossibly close for the time elapsed and speed flown. Gernon lands with 20 minutes gone on the clocks. Did he misread time? Did winds aloft push him faster than he realized? Could radar lag create the illusion of a leap forward? Perhaps. But his description of a tunnel echoes a class of cumulonimbus formations and boundary layer shear that meteorologists know can create severe instrument error and electrical phenomena. It is plausible in principle for microbursts, wind shear, and strong updrafts to create corridors of altered pressure that influence airspeed readings. It is less clear how any of that equates to a time gain. Here, the record stops and the mystery begins. From the air, we return to the geometry drawn across the Earth's surface by those who look for patterns. In the 1,950 seconds, researchers like Aimé Michel plotted UFO sightings across France and found alignments, straight paths called orthotonies. Skeptics warn that any large dataset will yield lines by chance. Statisticians remind us of confirmation bias. Still, when world maps fill with clusters along certain great circles, when disappearances and instrument anomalies repeat in specific zones, investigators take notice. Ivan T. Sanderson proposed 12 vile vortices, regions of magnetic and atmospheric peculiarity arranged almost symmetrically about the globe. The Bermuda Triangle was one, the Devil's Sea near Japan another. Critics object that the classification is imprecise. Supporters counter that the anomalies within those zones are measurable. Micromagnetic gradients, methane seeps that destabilize buoyancy, erratic squalls, and rare, powerful waterspouts. Both can be true. The map is imperfect, and the physics is real. Physics is the tool that separates sensation from cause. The planet is a dynamo molten iron convex in the outer core, generating a magnetic field. That field is not smooth. It is corrugated by crustal variations, remnant magnetization of ancient rocks, and currents in the ionosphere. Over oceanic shelves, gradients appear where basalt flows cool and lock in paleomagnetism. A compass is a slave to such subtleties. Add charged aerosol in humid air, electrified anvils that create street, Elmo's fire, and the occasional burp of methane from destabilized clathrates that can reduce water density, and you have a recipe for instrument error, poor engine performance, and rapid sinking that leaves little debris. All are documented. None explains all cases. Evidence that does not fit invites the other possibility: technologies we do not understand. On an overcast training day in 2015, Navy pilots off the Florida coast chased something the sensors could not reconcile. The object rotated without banking, held altitude against headwinds, and accelerated with no visible control surfaces or exhaust. Infrared imagery shows a cold envelope, not the thermal bloom of a jet. Radar corroborated position and speed. The video is public. The voices are calm. The expletives are real. Explanations include sensor artifacts, miscalibration, or a classified drone possibilities that deserve testing. But if even one frame is authentic as recorded, then there exists a craft with performance beyond current aerodynamic limits. Ancient stories echo with shapes that feel modern, acorn-like forms, discs, chariots that fly. In the Sanskrit epics, Vimanas travel between cities and stars, powered by engines that do not burn in the air. Are these myths metaphors for royal power and divine will, or garbled observations of technology out of time? Archaeology urges caution. Textual descriptions evolve, translations add flourishes, and retrofitting modern meaning onto ancient words is hazardous. Yet the poetic coincidence persists. Shapes carved in stone resemble frames in infrared. A temple spire mirrors an aerodynamic teardrop. A stupa crowns itself like a re-entry capsule. Symbolism is not evidence, but humans repeat forms for reasons they often cannot name. The camera now crosses a basin ringed by mountains to a dry lakebed in Nevada, where the air is clear and the horizon is guarded by signs that do not bluff. Groom Lake, Area 51. Here, the runway flees toward vanishing point, and the anecdotes thicken. Nocturnal flights without strobes, sudden darkness after a single takeoff roll, sonic booms that ricochet in patterns unlike any known aircraft. The base exists to test the edges of aviation. U-2, A-12, stealth shapes that seemed impossible when whispered about at truck stops. So why should it surprise us if other edges are tested here? Propulsion that leaves no plume, control without control surfaces, airframes that turn within their length. Declassified memos complicate the picture. An FBI note from 1,950 mentions recovered discs in New Mexico. Skeptics cite hoaxes and misinterpretations. Believers point to consistent testimony by military personnel who stake reputations and careers. Between them lies a procedural reality. Governments classify what they cannot risk others copying, and they deny what they cannot yet defend. The result is a fog in which facts and fabrications share a file folder. One fact arrived in 1967, not in Nevada, but in Montana. In a concrete capsule buried against war, an Air Force officer watches as green lights blink to red. 10 Minuteman missiles go offline in sequence. The system is designed to prevent common mode failure. The odds of simultaneous shutdown approach 0. Above, security teams report a bright object, hovering, silent. The cause is never officially tied to what the guards saw. But the men underground remember the timing, a presence above, a cascade below. Some call it interference, others call it a message. The narrative returns to saltwater and the geometry that began our story. Ships have disappeared everywhere on Earth. Planes have vanished over deserts and mountains. The Bermuda Triangle's numbers do not exceed, per mile, some other storm-ruled regions. But few places braid so many kinds of anomaly into one chord: compass variance, violent microweather, seafloor gas, complex traffic lanes, and a culture sensitized by famous cases. Exaggeration and misreporting thrive in such light, but so do genuine puzzles. For a pilot threading weather along a narrow fuel margin, the physics matter more than the myth. A spinning anvil cloud can create a bounded, weak echo region, a void that looks safe on radar but hides a downdraft. A microburst can win an argument with a loaded aircraft at low altitude. Lightning can temporarily saturate a magnetometer, driving it to nonsense. A GPS outage can force a reversion to instruments that disagree. A gas eruption can whiten a patch of sea such that buoyancy drops faster than a hull can compensate. Each of these can happen anywhere. Here, several often happen together. So what of time, tunnels, and orthotony grids and drowned palaces? A scientist should not fear the question, only the refusal to measure. If a vortex exists, it will leave signatures, microphysical profiles, electric fields, radar cross-sections, and a history of similar events under similar boundary conditions. If alignments are real beyond chance, they will survive blind statistical tests on fresh data. If sonar blocks our walls, they will show tool marks and foundations, not just natural bedding planes. If a craft can rotate against the wind without aerodynamics, then it pushes on the world by other means: field effects, reaction mass hidden from our sensors, or something we have not yet put in equations. The next hour is a journey through case studies, each one a node in the network. The Flight 19 transcripts, line by line, laid over reconstructed winds and drift. The PBM Mariner's accident history, a model known to be vulnerable to fuel vapor ignition against the hard fact that no wreckage was recovered. The Bruce Gernon radar plots, matched to known radar update intervals and range-folding artifacts, to test whether a ghost track could jump ahead without the aircraft doing the same. The orthotony dataset, randomized and replotted to see whether lines survive once our eyes cannot cheat. The Bimini Road slabs, measured for petrographic continuity. Are their joints natural stress fractures or seams? The 2015 Navy videos gimbal lock artifacts modeled on a FLIR turret, compared to frames where the background cloud deck suggests real rotation of the target. The Malmstrom outage records sequence, timing, redundancies compared with known failure trees. Patterns emerge. In some cases, natural explanations fit snugly once all variables are included. In others, an X remains on the chalkboard. Perhaps the most important pattern is this: the mysteries tend to cluster where measurements are sparse. Over open ocean before satellites, in storm cells that eat aircraft, in classified zones where witnesses cannot speak, in subterranean bunkers designed not to broadcast. As instruments improve and datasets grow, ghosts sometimes become wind shear and sometimes remain ghosts. The film slows, the music thins, and VERTEX takes a breath. Awe is not an argument. Skepticism is not cynicism. A scientist can be both enthralled by the unknown and relentless in testing it. The Bermuda Triangle does not demand belief, it demands attention. Because whether the cause is a quirk of microphysics or a technology that erases its own wake, the result is the same for those who cross it unprepared. We leave the water and follow the grid lines to the desert one more time. There, beyond fences that hum with warnings, engineers may be flying tomorrow's aircraft in today's sky. If we have learned to shape air with fields rather than wings, to move without exhaust, to pivot without lift surfaces, then a part of the triangle's legend becomes a mirror. The impossible maneuvers are ours. If we have not, if what streaks and turns above the Atlantic is not stamped with any flag, then another part of the legend leans forward. Someone else is here. History suggests a third option: many phenomena, many causes. Some losses in the triangle are mundane tragedies: weather, error, and unforgiving sea. Some sightings are misidentifications or artifacts. Some cases remain unsolved because evidence sank beyond reach. And perhaps a small remainder points to physics we barely grasp: plasma coupling in storm electrics, transient magnetic reconnection in the ionosphere, or machines that ride gradients we only recently learned to measure. Night over Miami again. A commuter jet lifts through layers toward cruise, turning east toward sunrise. Passengers drowse. A child watches wingtip vortices write soft hieroglyphs on the sky. In the cockpit, checklists tick forward, as they always do. Somewhere out over the Bahama banks, a buoy nods on a swell above a depth that might hide an Avenger or none at all. The ocean is patient. The sky is generous. And the unknown is not an enemy, it is a frontier. Across centuries, from Columbus's compass to Gernon's tunnel, across maps, from orthotony lines to Sanderson's vortices, across myths, from Atlantis stones to Vimanas in verse, across cameras, from Navy FLIRs to runway lights that go dark at Groom Lake, across concrete, from missile silos in Montana to the unblinking red lamps that kept watch, the through line is curiosity. Humans draw triangles where data is sparse. Then we fill them, point by measured point, with instruments and skepticism and wonder. If there is a message in the triangle, it is not only about danger. It is about humility. Instruments fail. Assumptions fail. Sometimes explanations fail. The correct response is not surrender but better instruments, fewer assumptions, and explanations that earn their place. And if there is a warning in the UFO over the Atlantic wind, or in the object that paused over nuclear silos, or in the craft that left no wake, it may be this: our technology and our ethics must evolve together. Any intelligence able to move like that can swat a missile field like a fly and choose not to. If that choice was real, it is the most important data point of all. The sea darkens. The camera climbs. Florida glows. The ant trails of highways flicker. The ocean becomes ink. The triangle, if there is one, is not drawn on the water. It is drawn in the mind, connecting the known to the unknown, the measured to the imagined, the story to the study. The lines shift as new data arrives. That is how it should be. If you have crossed these waters, flown these routes, searched these archives, or stared at those videos until dawn, you are part of the map. Share your coordinates. Add your measurements. Correct our course. Together, the triangle becomes a network, then a theory, then a lesson. This is VERTEX. Thank you for journeying with us through currents that twist and skies that fold, through archives and legends and laboratories. If this episode moved you to think, to question, to measure like the video, subscribe to VERTEX and ring the bell so you never miss our next expedition into the edge of the known. Now it's your turn. In the comments, tell VERTEX is the Bermuda Triangle, a map of human pattern seeking, a collage of natural hazards, or the shadow of a technology not yet ours. Until next time, keep looking up, stay curious, and remember the universe and the oceans of our own world always have more secrets waiting to be revealed.